The topic of this video is dilution. So we often have a concentrated solution, like the one below on the left-hand side. And in lab, we want to use a lower concentrated solution. So we take what we call a stock solution, and we figure out what volume we need in order to make a lower concentration and a new volume of that solution. A couple things. Number one, the reason that this particular formula works is because the moles of solute do not change. So the moles of solute in the concentrated solution equal the moles of the solute in the dilute solution, because all we're doing is we're actually decreasing the molarity by increasing the volume. But overall moles actually stay the same. A couple things about the stock solution. It tends to be darker if it has a color. The diluted solution, again, will be lighter. We'll see fewer particles dissolved in equal amount of solvent in the lower concentration than we see in the higher concentration. So just looking at these particle diagrams, we can tell the higher concentration has more solute particles dissolved in that same area, where the lower concentration, we have fewer solute particles dissolved. And again, the overall moles of solute don't decrease. The volume or the amount of solvent particles actually increase. Another way to take a look at this is through what the process looks like. And what I like about this particular example is instead of using C for concentrated, they actually use S for stock. So in a typical chem lab, we keep higher concentrated solutions. We call them stock solutions. And so what we figure out, or what we're going to calculate, is what volume of stock solution we need to make the more dilute solution. So you can see in this particular example, we've got our stock solution here. We've calculated what volume we need. We're using what we call a volumetric pipette to pull up that more concentrated solution. We deliver it to an empty, whatever volumetric flask you need. And then what we do is we fill to the graduation mark with solvent to make our more dilute solution. We're going to use this formula to kind of help us calculate what volume of stock solution we needed to draw up originally into this pipette to make this more dilute solution. Again, you can see number one, darker solution here for our concentrated. Our dilute solution is a lighter color. The calculation's pretty straightforward. Let's see if we can take a look at an example. I want you to describe how you would make 250 milliliters of a 1.25 molar solution from an 18 molar hydrochloric stock solution. So we have 18 molar hydrochloric acid. What volume of that stock solution are you going to need to collect? So here's a great place to pause this video. See if you can calculate that and see if you could describe how you would actually make that solution. Okay, in calculating this, using this formula, molarity of the stock solution, or the more concentrated solution, times the volume of that stock solution is equal to our new molarity of our dilute solution times the volume that we want of that dilute solution. So we know our stock solution has an 18.0 molar concentration. What we don't know is how much of that we need, but we know our new solution with lower concentration, we want 1.25 molar, and we know we're going to make 250 milliliters of that. Now, because molarity is going to cancel out, I'm actually just going to leave my volume in milliliters. You can convert it to liters if you want to, but it's really not necessary. When we figure out X, we figure out that we need 17.4 milliliters of stock solution. So we're going to take a volumetric pipette. We're going to draw up 17.4 milliliters of that 18 molar stock solution, and then we're going to deliver it to a 250 milliliter volumetric flask. Then what we're going to do is take our distilled water, and we're going to fill that 250 milliliter volumetric flask to that graduation mark. So we're not adding 250 milliliters of water, we're filling it to that mark. And then we're going to invert several times to mix. That's pretty much it. It's a simple calculation. The premise is the moles of our solute don't change. at all, but our concentration goes down because we're diluting it with more of our solvent. So you're going to need to be able to do calculations like this, and you're going to need to be able to explain using proper glassware how you would perform a dilution. That's it.